The function f has derivatives of all orders for real values of x. Pause, think. Good to know, because we need this thing to be differentiable for the first n plus 1 derivative, so this thing is derivativable, not a word. You can take the derivative of it forever. P sub n of x represents the nth degree Taylor polynomial. We knew that. That's the representation anyway. For the function at x equals 1. Stop right there. You already are gaining some information. I know this function is centered at 1. Now, I know you're saying like x equals 1, but c equals 1? Okay, they told you where it's centered. They used the variable x, but that's where it's centered. I'm just writing down what I know. The graph below represents the fifth derivative of x. Okay? Show that, whoa, and then all of a sudden we get overwhelmed. Well, don't panic. Let's just start looking. We're dealing with the fourth degree Taylor polynomial, right? So we have an n of 4, right? Of course. Well, the x value that we would plug in is 3/2. I'm just writing down stuff I know. Maybe I can think of what to do with this disgusting mess. Well, let's just start, easy for me to say, brainstorming some other ideas. And here it is. This needs to be less than 100, and even if that looks a little overwhelming to you, just look at this. That is this right here. The function minus the Taylor polynomial is equal to the error. Okay, good. I'm going to write that then. This is, and I'm writing way too much, so I'm just explaining here. If this was a free response question, don't overdo things. But this guy right here, f of 3/2 minus p sub 4 of 3/2 is equal to r sub 4 of 3/2. Okay? Well, what's this equal to? It is equal to the Lagrange error bound, actually less than or equal to the Lagrange error bound. So that would be this guy right here. And let's just keep writing. We're going to keep writing this thing. So this is going to be that. Now, lucky us, we have found some of the values we're dealing with already. So I'm about to write this. What we've done is interpret this problem by just picking apart everything I know, listed on the side, say that looks familiar, I know that's equal to that, and this should be, and if you're tempted to put like 1 over 100, let's not play that game. Let's figure out what this is. And then in a minute, we're going to be like, oh, well, this is less than or equal to something, and oh, and that sure is less than 1 over 100. All right? Work with me here. If you're confused, do not panic. Do not panic. It's like when people scream, don't panic, and you panic. It's not that bad, I promise. All right. Absolute value of x minus c to the n plus 1. The more you write it, the more you'll remember it, but I've already started plugging in variables, so here we go. X minus c, absolute value of that, to the n plus 1. 4 plus 1 would give me 5. I mean, obviously, right? We're in calculus. Over 4 plus 1 factorial, so 5 factorial, multiplied by the maximum thing that I could possibly get, well, absolute value of that thing, of the fifth derivative of z. What's z? I don't know. If I knew z, we could figure this thing out, and that's kind of the point. So we don't know z. All right, we have a mess. This is equal to something, and we're going to figure out what that something is. So what they gave us is equal to this, which is the Lagrange error bound, Lagrange, however you want to call it. This is 1/2 to the fifth, 1/2 to the fifth power, over 5 factorial. Let's go ahead and do that. 5 factorial is 120. Remind me to tell you something hilarious later. And then maximum thing that the fifth derivative could be. Maximum thing the fifth derivative could be on the interval or in the interval containing c and x. So from 1 to 1.5, what's the biggest thing that the fifth derivative, that's what this graph is, right? That's what this graph is. What's the biggest thing that the derivative could be? Well, technically it's not 4, it's a little less than 4, but we're gonna go with 4 because we're just eyeballing it. This is just an error bound. So it's not gonna be perfect, of course. So that 4 is just a little bit beyond that 3/2, but I'm not gonna be like, well, that looks like 3.999. No, we're just gonna call it 4, okay? And absolute value of 4, of course, is 4. So 4, with the wrong color, nonetheless. That's just tragic. I'm gonna go with it. And I don't have my whiteout with me. Oh, yeah, there it is. It was under a piece of paper. We'll stick with it, just, for contrast. There we go. So what we're going to do is figure out what this is. This had better be less than 1 over 100, and then we will be like, oh, mission accomplished. So here goes. This is 1 over 32 over 120, and then we're going to put that 4 up in the numerator with that. So put the 4, and it's wrong color still if we're going to color code these. But 4 over 32 is going to give me 1/8. 1/8 over 120. 1/8 divided by 120 is going to give me 960. So 1 over 960. Stop. Think. Is this less than 1 over 100? Yes. You just found the Lagrange error bound to be 1 over 960. So our estimate is within this, which is definitely less than 1 over 100. Mission accomplished. It is confirmed.